Thank you very much for this generous introduction, Uzay, and thank the organizers, especially Dimitar Filev, for inviting me to speak at this conference. It's a pleasure to be here and to share with you some of our research ideas around constructing models for dynamic systems, specifically from data, so machine learning models, and then with emphasis on transparency of these models. So we are typically not using much of deep learning and multi-layer networks, and also being able to use prior knowledge so that we get models that are physically consistent. So as already mentioned, my background is in systems and control, and this field puts a lot of stress on model-based design and then provably correct and guaranteed closed-loop performance. And this, of course, comes at some cost, and the cost is typically that you have to restrict yourself to some classes of systems, like linear time invariant systems, for instance. And once you don't satisfy these requirements or restrictions, you cannot use these techniques, or you can use them, but they often underperform. So I was always interested in combining traditional control approaches with machine learning methods, nature-inspired methods in general, and with learning from data. And we used to call this in the old days intelligent control. Now I prefer the term learning control, because intelligent control doesn't have any stupid control as a counterexample to that. So I'm very much involved in learning control, and I want to give you some flavors of that in the first part of the lecture, and then I will focus on one particular method that we used for learning models from data. So the first interest of my research teams, both in Prague and in Delft, is reinforcement learning for the sake of nonlinear motion control, usually in robotics, but it can be any type of dynamic systems. And you can use reinforcement learning in many ways. So one of them is to optimize performance, specifically if you have repeated or repetitive tasks. Then you can use basically any sort of learning, also iterative learning control and so on. But I'm specifically interested in reinforcement learning to improve the performance throughout the operation. And I have an example of that, which is essentially quite a simple, straightforward robot arm. So you see a bipedal walking robot here doing what we call trials in reinforcement learning. So essentially standing up, trying to make a step, receiving rewards or penalties depending on the success rate. And we were hoping to get this work on the real robot. No way to get this work. We always broke the robot before we could achieve any improvement in the control performance.